Hello YouTube, I'm Arend Peter. Today I'm going to be showing you how to add a lever to your game which can open gates. So you'll see the final product on the screen. So as you can see, I have a player which can move over to a lever, press space, and open a gate. So let me go ahead and show you my starting point. All of the code for the starting point, the final project, as well as credit for all the art assets is in the description. So you can go there to get all of that. So I'm just going to go and walk through it. I have some sprites, I have some tile sets, I have some rooms inside and outside, which are right now purely aesthetic, just a bunch of tile layers, but we're going to be adding objects there later. And speaking of objects, I've made two objects, just a solid, which just has the solid box checked, nothing else, and a player, which just has basic movement code for moving left and right. So that is all of our setup. Let's jump into it. So if I go to my sprites, we're going to be working with two sprites primarily. That is this gate, which is just, a gate. And I should note that I edited the original gate to make this a little bit taller, and I also edited the doorway and the tile set to make it taller, which you'll see later. Then the other sprite we're working with is the lever, and I should note that I actually made this pixel art, so you can blame me for the pixel art here, not the original artist. Yeah, I needed a lever, so I made it match the aesthetic of the tile set. So I actually have two frames here, one with the lever to the left and one with the lever to the right, and that's all there is to that. And let's go ahead and make objects for both of these, the gate and the lever. So there we go. I set the created objects, set the sprites. Pretty standard stuff. And then we're going to be starting with the lever. So the way we want this to work is the player will walk over to the lever, press space, and then the lever will toggle. So we want to check that it's overlapping with the player and space is pressed. So we're going to go ahead and go to step event to write that logic, and I'll go ahead and start it. There we go. The circumstance is primed to toggle. We are colliding with the player and they press space. So next we want to toggle the frame. So if the frame is 1, we want to set it to 0. If the frame is 0, we want to set it to 1. So we could do this with an if statement, like literally write out if statement as I just said it. However, there's a much more elegant way, which I'm a fan of, so I'm going to go ahead and type that out here. So here, as you can see, if the image index is 0, then 1 minus the image index will become 1. If it is 1, then 1 minus 1 will become 0. So there you go. That's a handy trick to toggle a frame. So in order for this to work in game, I also need to go in the create event and set the image speed equal to 0, so it's not like animating the lever going back and forth like crazy. So next, in order to test out this lever, we need to add it to the room, and it's actually a little bit more involved than usual. So I'm going to jump into arm outside, which I have set to my home room. So as I said earlier, this is just tiles, but I've got a couple of particulars in how I ordered these layers. And I'm going to make a player layer. I never noticed that how nice those sounded together before. Player layer. So what I want to happen here is when the player moves through this doorway, I want it to actually look like it's moving through the doorway. Right now that's not the case. But because I have these layers set up in a particular way, we can make it the case. So you see I have this tile door right with where I've placed all the tiles that are to the right of the door. So as long as the player layer is below this tile door right layer, it should look like the player's walking through the door. So I'm swapping those, enabling the rest of the layers. Then you can see when the player moves through there, it looks like it's moving through there, which is a pretty easy way to add a little bit of a 3D effect to your game. Yeah, pretty cool. So on that note, we have something similar for the gate. So I'm going to make a new layer for the gate. We got the gate. Let me just zoom in here and make sure I got this pixels lined up. There we go. So now when I move the gate up, I want to actually go behind there. So we have a similar thing where I actually drag it below this tile foreground, and then it'll go behind there properly. Excellent. And last but not least, need to add the lever. And my default size is massive, so I'm going to go ahead and change the scales to 0.5 each. And then I can move the lever over here to the left of the player. Excellent. I think we're ready to play. Let's play. And there you have it. I can walk over to the lever. I can press space to toggle it. If I press space away from the lever, I can't do anything. And yeah, that works. So now that we got the lever working, we can go ahead and implement our gate logic. I'm going to go ahead and give the gate a variable. I'm going to call it activated. I'm going to set it equal to false. And then I'm going to go back to the lever. And over here, in addition to toggling our image index, we want to toggle that activated variable in the gate. So we do that is gate.activated equals not gate.activated. So teaching all these tricks today. This is how you toggle the 1 and 0, and this is how you toggle a Boolean variable. If it was true, set it to not true or false. If it was false, set it to not false or true. Actually, I can write that as not instead. Let's make it a little more readable. Okay, now we can go to the gate. So here's what we want to do there. So I'm going to go ahead and make this little if-else statement based on whether we're activated, and for each case we're going to set our y position differently. So if we're not activated in this else statement, we actually just want our y to be equal to the y where we started at, our y start. And then if we are activated, we want to shift ourselves up by a certain amount. So we can actually go into the room, and I'm going to go ahead and click on the gate. And if we look at its y position, it's currently at 160. Then if I inch it upwards and try and figure out exactly where I want it to be at, which one looks good? I think right there it looks about good for the upward position. So that's 133. 160 minus 133 is 27. So 27 is the magic number. So in the create event, I'm going to create a new variable called shift y and set equal to -27, because that's how much we want to shift the y by. So if we're activated, we want to say y equals y start plus shift y. So that's how you do this with an if statement. And as you might have noticed, getting rid of if statements is kind of a hobby of mine. It makes your code shorter, it makes it ever so slightly faster because it's avoiding branch logic, and most importantly, it makes you feel clever and gives you bragging rights to all your friends. So let's talk about how to not do that if statement. And here's what that looks like. There you go. So this leverages the fact that GameMaker, true-false variables like activated, those are actually the same as 1s and 0s. So when you are setting something to true, it's just setting it to 1. And when you're setting it to false, just setting it to 0. Which lets you do nice little math statements like this, where if activated is 0, we just have the y start. Like this part is completely canceled out. But if activated is 1, it'll include this shift y and become this statement. So this is something you can do in a lot of cases where you can have a base, and then you can multiply whatever you're adding by the Boolean variable, the true-false variable, and then you end up with that. So I'm going to comment that out. And I think we can test this out. So I move over to the lever, press space, and it's open, and I can walk through. Brilliant! Brilliant. Okay. I suppose I should make it solid so I can't do this nonsense. That wasn't part of the tutorial, but I can do it. Let's just make solid equal to activated. Actually, not activated. So if we're activated, meaning the door is open, we want to be solid equal false. If we're not activated, we want solid equal true. So that should work there. There you go. Yeah, nice. Okay, so the next thing I want to do. So we have a little bit of a arguable flaw in our logic. This can kind of bite us in the future. So right now we have ogate.activated. Like we're toggling the activated state by saying ogate. So the problem there is, what if we have a room with many levers, many gates, and we want to kind of wire each lever to a specific gate? Well, we don't have control of which gate we want to be activated in this case. So let me go ahead and show you how we would wire it up with a specific gate. So I'm just going to create a gate variable on this lever, and I'm going to do it, instead of doing it in the creation event, I'm actually going to do it using variable definitions, which is essentially the same as creating a new variable in the creation event, but this has some extra benefits which we'll go over later. I can probably tell you one of them right now. If you are working with other people, it's a lot easier for them to modify variables to this variable definitions section rather than jumping into your messy creation event. Okay, so we're going to have a gate, and we want this to reference the gate instance, and there isn't really a clear mapping here for the gate instance. So whenever that's the case, you just use expression, which lets you just input an arbitrary GML statement. So we have the gate variable, and then over here we can say gate.activated and gate.activated. Okay, so now if I jump back to the room, the really cool thing about the variable definitions is you can set it differently for each of these instances. So if I click on this lever, I can access the variable definitions here. So I'm going to go and edit it, and then here we want to put in the ID of the gate we want to adjust. So if I click on this gate, I can see the ID up here. So I'm going to go ahead and select that, copy it, and then go over here into this variable, paste it right there. And that should still work. Still works. So now you can set up multiple levers, multiple gates, and you can wire it up to your liking. Okay, so this could be the end of the tutorial here, now that I've shown you how to do this lever gate pattern, but this could be generalized further to what I'm going to call a trigger activatable pattern. And you can use that in a load of different scenarios. So let me show you how to generify this into trigger and activatable. Alright, so let's go and get started on making this generic. So I'm going to make two objects. One I'm going to call trigger. The other one I'm going to call activatable. So trigger is the generic version of the lever. So I'm going to have the lever have its parent be the trigger. Okay. And then over here in the create and set event, I'm just going to go ahead and add event inherited to make sure that I take advantage of any code that I've inherited from my parent, from daddy. Okay. Or mommy and daddy rather, to be inclusive. So next I'm going to go over to the gate. Its parent is going to be the activatable. And then I'm going to go over here. You know what, to be fully inclusive, I should have said mommy and daddy, daddy and daddy, mommy and mommy. That's actually quite a difficult statement to get right. I probably shouldn't have gone there. Okay. But yes, there are many ways families can be structured. Okay. Activatable. All right, so now we have inherited, and we have event inherited in all of our events. We have gate inheriting from activatable, and lever inheriting from trigger. So now let's go ahead and handle whatever shared code is going to be in them. So in the case of activatable, all it's going to have is it's going to have this activated equals false in the creation event. So I'm just going to cut it out of the ogate and put it in activatable. So that way the gate can receive this activated equals false logic, as well as anybody else who's a child of O activatable. And that's actually all for O activatable. So if I go to O trigger, that one's a little bit more involved. All right, so now let's move on to O lever and its corresponding O trigger object. So here, instead of referring to gate.activated, which is gate is our specific activatable for the lever, we want to think of it in a more generic way. I'm going to change this to use the set activatables function, and we're going to create this function in a second. So if I put down true here, it's going to set the activatables to true, and if I put down false here, it's going to set the activatables to false. So if I think about my image index, I can determine whether I want it to be true or false based on image index. I'm going to do a quick ternary operator here. If it's equal to 0, I want the activated of all of my activatables to be equal to false, otherwise true. So that's what we're going to do there. Now let's jump over to the implementation of set activatables. So I'm going to go to O trigger, and then in the creation event, I can define the function. And then we're going to, as an input to the function, we're going to take activated. Okay. So now we need to set up a variable definition. So if I go back to O lever, we can actually delete this gate definition in favor of the parent definition. O activatable, no, O trigger. So we're going to add here activatables. So notice previously we just had a singular gate. Now we're moving from a singular gate to multiple activatables. So this can more powerful than what we had earlier, where we can actually have a single trigger activate multiple things. So we're going to have an expression here again. Since we have multiple things, you'd think a list would work, but the problem with list is you need to predefine what the list items are over here. But in our case, we're going to use an expression which will allow us to specify an array. And an array, of course, is essentially the same as a list. Like, if I'm getting technical, the list is a more generic term, and array is a specific type of list. But we can select expression and specify the activatables using an array. So yeah, so now we have an activatables array that should be available to us from this function. So whenever this function is called, we want to loop over this array and set the activated of each of the people in that array to whatever this variable is. Okay, so let me show you how to do that. Alrighty, so here this loop is setting I to 0, and then it's continuing to increment I until we are at the length of activatables. So I is gonna go over the range from 0 to whatever the length of activatables is. So on the ith activatable, we are setting its activated value over to activated, which this one is yellow, meaning it's a local value. So remember this dot, it's like an apostrophe S. Okay, cool. So now if we go over to our room again, I can go into the variables of this lever, and I can need to set that activatables field again. So if I go over to the gate, get its instance ID, I can just do it like so, or have an array with that guy. And then I can add commas to add more if I wanted to. Okay, let's verify that this still works, and then I'll show you how we can do this in another context. Still works, brilliant. So note that the lever is using the set activatables function. So it's not doing as much on its own. Its implementation is specific to the lever, which is how it's triggered and the frame and whatnot. Okay, let me show you how we can do this in a completely different way. So I'm going to set up a trigger zone, and if the player walks into that zone, enemies will drop down from the skies. That's what we're going to try out. So I'm going to make trigger zone, which I'm going to set to, let's see, I'm going to give it sprite. I'm going to give it a parent of O trigger, and then in the step event, I'm going to do something similar to the other one, right? You start with the event inherited, and then if the player collides with this guy, I want to trigger my activatables. Just like that. That's all the logic in this guy, just a simple if statement like that, and the rest will be handled by our trigger. So Now I can also make my Goomba enemy. I have other tutorials where I use this enemy as a Goomba, so hence why I'm naming it Goomba, just to be consistent with my other tutorials, even though we're not doing any Goomba stuff right now. So it's setting the sprite to simp, and I can set the parent to be O activatable, like so. So all I want to do with this guy is if activated, I want to manage its dy, so I'm going to right click on create and hit inherit, and I'm going to set dy equal to 0, dy being our vertical speed. So if we're activated, then I want to apply gravity, so dy equals plus equals 0.5. Then I want to keep applying gravity until we hit the ground, and in theory I should do like proper collisions here, but I don't feel like it, so I'm going to go to arm inside and kind of experiment a bit with these guys. So this is where I want this scenario to happen. I'm going to move the player to the left, and I'm going to set the trigger zone here in the center. So the player is going to walk into the trigger zone, enemies fall from the sky. So enemies are going to start up here, but I need to figure out where I want them to stop. So maybe about there, the same y value as the player. So I double click it, the place I want to stop is at 160. So I'm going to go ahead and move that guy up there, make another one, flip him. There we go. And then over in my Goomba, I can have dy plus equals 5. I can set, say, y plus equals dy. And actually I could do this a little bit more interestingly. Either I want y to equal y plus dy, or if that's bigger than that 160 that we discovered earlier, I want it to just be 160. So I want to do whichever one's smaller. If you're still smaller than 160, you're still above it in the world, then keep adding dy. Once that becomes too big, then the 160 will be the smaller one, and it'll equal 160. So that's all the logic for the Goomba. Again, there's no logic whatsoever for like figuring out how to trigger it. So yeah, let's test this out. So I'm going to set the room over here. I'm going to set this guy to be the first room, and then let's see what happens. So we walk into the trigger zone, and nothing happens, and that's because we did not wire up the activatables in the room. So this guy's code is that. If I go into the trigger box, change activatables variable, you see that's currently empty, and we need to add that left Goomba in there. And I'm just going to go and copy the right Goomba as well, like so. So now we walk into it. Enemies fall from the sky. Scary. So that's pretty cool. Yeah, so you've seen right here that we've taken the same pattern, applied it to a completely different scenario. And I'm just going to go and make the trigger zone set to invisible, so that way it looks a little bit cooler. And you can wire this up however you want. You can have the trigger zone trigger the gate. You can have a lever trigger the Goombas if you wanted to. You can, put whatever activatable you want in your triggers. So it's very flexible with this system. So that is all for this tutorial. Thank you so much for watching. This video is actually part of a playlist where I'm making this castle-themed platformer game. So every single feature you see in this little demo on the screen is something I made a tutorial for. So if anything is interesting to you, check out the playlist and you can watch the tutorial for how to make that specific effect. So yeah, thank you guys again so much for watching, and I look forward to seeing you next time.